Well, welcome to this online revision session for AQA FP4, which we're going to look at the June 2010 question 6 on vector geometry. As you can see in this question, we're given the equation of a line and a plane, and we have three parts to look at. The first part, we're considering the direction cosines and the perpendicularity of the line to the plane. And in the second part, we're going to solve a set of simultaneous equations, which leads into the third part, where we're going to find the point at which the line meets the plane using your results in part B. Okay, well, let's try the first part of this question. We need the direction cosines for the line L. Well, the direction vector, if you remember, is given by the 6 to negative 9. Remember, the first part, the first vector gives you the position of a point on the line, and then the t lots of the next vector is the direction vector of the line. And so the direction cosines are found by dividing each component in turn by the length of the vector. And we can see that the length of this direction vector is given by the square root of 6 squared plus 2 squared plus negative 9 squared, which will give us a result of 81, 85 plus another 36 makes 121, and the root of 121 is fairly obviously 11. And so our direction cosines in turn will then be 6 divided by 11 and 2 divided by 11 and negative 9 divided by 11. Okay, and we could just put a bracket around those to show each one of those in turn. And then, in part 2, we've got to show that L is perpendicular to the plane. There's two ways you might consider doing this. You can either take the cross product of the two vectors in the plane, and then that will give you the normal to the plane, and if that normal is in the same direction as the line, then you obviously know that the line is perpendicular to the plane. Or alternatively, you can do the dot product of the direction vector with each of these vectors in the plane, and if it's perpendicular to two independent vectors in the plane, then it must be perpendicular to the whole plane. So let's go for the second one out of those, sorry, the first one out of those. We'll do the vector product. And so if we take the vector product, 5, 3, 4, crossed with 1, 6, 2, and we'll do it with the method without using a determinant. So then it's, for the x component, you take the determinant of 3, 6, 4 and 2, so that's 6, take away 24, so that gives you negative 18. For the y component, it will be the determinant of 5 and 1 and 4 and 2, so that's 10, take away 4, which is 6, but you have to remember that second one is a negative from the plus minus plus. And then the third one, for z, it's the determinant of 5 and 6 and 1 and 3, so that'll be 30, take away 3, which is 27. And so we can see that this vector, which is normal to the plane is actually going to be -3 lots of the 6 to -9, which is the direction vector. So we can see that the normal of the plane is equal to -3 lots of the direction vector of the line. Okay, and so you need to say something to that effect. That the normal is in the same direction. So the normal is in same direction as the line. Which thus implies that L is perpendicular to pi. Okay, where do you get the marks then through this? Well, in the first part, you get 1 mark for some sort of appropriate method and an accuracy mark for getting them all correct. Excuse me. In part 2, again, for an appropriate method, whether it's using the cross product or using the dot product on both parts of the plane, with the vectors contained within that plane, you'll get a method mark and then an accuracy mark for finding the connection between the normal and the direction, and then for a statement showing that you understand why this shows that it's perpendicular, you will also be given a mark. Okay, into part 2, or part B. Well, here you're given a system of equations which you're being asked to solve, and the first part here we're saying we've got to eliminate R so that we just have a pair of equations with P and Q. So if we call this equation number 1, this one number 2, and this one number 3, making certain we show the examiner what it is that we're going to do. So the first part we may well, let's say, take twice 1 and subtract 3. And that will eliminate the R's from that pair. So we get 12p take away a -9p, so that's 21p. And you got 2 times 5q is 10q, take away the 4q will give us 6q. The R's will cancel, and then we've got 9 doubled is 18, and 18 from take away the 75 will give us -57. So that's given us one equation that's true. So now we're on a second one. So if we took equation 2 and then subtract 3 lots of equation 3 from it, that will again eliminate the R's. So it's equation 2 minus 3 lots of equation 3. So we've got 2 take away -27, so that will give us 29p. Then the Q's will have 3 take away 12 lots of Q, so that's -9q. And that will equal 16 take away the 75. Sorry, it's not 16, is it? It's 8 take away 3 lots of 75. I think I had a short circuit on my brain there. So it's 8 take away 3 lots of 75. 3 lots of 75 is 225. take away the 8 gives you negative 217. So there is the pair of equations with just now P and Q in them. So we've got to solve this pair. So if we multiply, well, again we'll label these, call this number 4 and this number 5. And if we multiply number 4 by 3 and number 5 by 2, and add them, that will eliminate the Q's. So we got 3 times 21 is 63, 2 times 29 is 58, so that makes 121p equals, and if we do the same there, we're going to get 3 times that is 171 and 2 times that is 451. 2 times that is 434, my apologies, and that makes a total of negative 605. So from that we can clearly see that P is equal to negative 5. So then we can go back and substitute that value in either equation 4 or equation 5, and you will find that Q will equal 8. And if you substitute both those values back into the top equation number 1, that will again give you that R is negative 1. Okay, so 5 marks involved here, so a method mark will be applied if you've attempted to eliminate the R's from these equations, and if you've got your 2 equations, each one that you get correct you'll get a mark. And there's obviously there is a third alternative there that you may have decided to eliminate the R's by using 1 and 2 combined together as an option as well. And again, if you manage to then show what 121p is, or getting a method mark through this part, and then obtaining the correct values will give you an answer mark there. Okay. Then we go into part C. It says, given that L meets pi, that's the line intersects the plane at the point P, you've got to demonstrate how P may be obtained from the system of equations. Well, that's not totally obvious. So you need to think firstly, what does it mean? If L intersects pi, then to find a point of intersection, it's where the pair of equations are equal to each other. So you've got to put the line equation equal to the plane equation. And if you do that, you will get 3 equations. You will get 7 plus 60, the x component, is equal to negative 2 plus 5 lambda plus mu. The second one you'll then get is that 8 plus 2t equals 0, 3 lambda plus 6 mu. And then the final one will be 50 minus 9t equals negative 25 plus 4 lambda plus 2 mu. So if you rearrange each of these equations in turn, you will have the fact that 9 equals negative 6t plus 5 lambda plus mu. The next equation will give you the fact that 8 equals negative 2t plus 3 lambda plus 6 mu. And then you've got 50, plus taking away that 75, the 25 gives you 75, equals 9t plus 4 lambda plus 2 mu. So here is your system of 3 equations. And if you compare that with the system that we had before, they are very similar in that R corresponds to mu, lambda corresponds to Q, and P corresponds to negative T. So there is a direct connection between the two. And then it says in part 2, hence determine the coordinate of P. Well, what did we do in part B? Well, if we look back, we solved the equations. We found that P was negative 5, Q was 8, and R was negative 1. So that tells us if P was negative 5, that T now is 5, Q is equal to lambda, so lambda is now 8, and R is equal to mu. Well, R was negative 1, so that means that mu is negative 1. Now we want the coordinate of P, so to find P we can either substitute the values of lambda and mu in to find R, or we could substitute the value of T, which is going to be 5, into there. So if we take, let's say, T as 5 and substitute in, we get 7 plus 5 times 6, so that's 37. We then get 8 plus 5 times 2, which is 18. And then we get 50 plus 5 times negative 49, which will give us 5. Okay, so where do we get any marks in this lot? Well, the first part we got 2 marks, so we get 1 mark for obtaining this set of equations, and then an accuracy mark for relating T and lambda and mu to P, Q and R. And then in part 2, which is really starts here, I'll label this here, we can then identify that we're substituting either T as 5 or the 2 values of lambda and mu, whichever one you chose to do, and that will give you a method mark, and then we'll have an accuracy mark for obtaining the correct value of P. Well, hopefully you found that solution helpful. For more work and support for your further maths revision, please go to the Further Maths Support Programme website.